Okay, so we're beginning with the chassis, and we are first going to put in the screws for the L bracket here. Then we place the motor into the bracket. Gotta be careful with the orientation there. And we secure the motor to the bracket like so. We place the bracket onto the plate, the acrylic plate, and now we begin to tighten the nuts on the other side. Okay, and now that the motor is secure on the acrylic plate, put on the wheel. Let's tighten the screws here. Make sure that everything is tight. And that's pretty much it for the wheel. And now we can put on
standoffs that will
hold up the other acrylic plate on top. And that is pretty much it. Okay, so now we do the same thing 4 times, and we've got all 4 motors and wheels ready, and we can place the top acrylic plate like so, and all we have to do is tighten the bolts on the supports, and that is pretty much it. We are done with the structural part, or the chassis, just like that. Great. Okay, so let's move over to the wiring part. Okay, so here we are. We're ready to wire the motors, and as you see, I have each one of the motors with 2 wires, a red and a black for every one. And as you can also tell, they are in the same order. All the reds are on top and the blacks are on the bottom, just to keep the polarities right. So in the case of a motor, the electricity runs through one wire and out the other one, and that makes the motor spin, much in the same case as with the LED. When electricity ran through it, the LED would light up. So in this case, instead of making LED light up, we're making the 4 motors spin. And we're going to have to connect these red and black pairs to what's called this driver shield. So this driver shield makes it really easy for us to connect each one of the motors individually to the terminals marked M1, M2, M3, and M4. Each one of those terminals has a positive and a negative terminal to which you can connect the corresponding wires. And that is what we're going to be doing with each one of our 4 motors. And then what we're going to do is we're going to take our power source for the motors and plug it into the shield over here, where the power is fed into this driver shield, because that's one power source. And the 9 volt, we're going to keep it as the power source for the Arduino Uno, which is on the bottom, through the barrel jack that we already know. So we're already putting together some of these concepts about power that we started to touch on previous videos. Alright, so we're ready for the wiring step. So we have our 293 shield over our Uno, and as you can see, we have the red and black pairs coming out of the bottom of the chassis onto our L293D shield, each one connected to the proper M terminals, one to the M1, one to the M2, M3, and M4. So the wiring our motors is complete, and now we want to wire in the power source. Now, before you ever wire in power sources, you want to make sure that the voltage that you expect from the power source is what you're actually getting. So we're going to very simply take these 2 leads, the plus and negative from the battery holder, and test them with our multimeter. So plug in the black cable to the black ground lead and the red cable to the red positive lead. Okay, our meter is reading 0, but it is properly connected. And what we need to do is complete the circuit through the wires. Okay, so keep your eye on the meter, and I'm going to plug in the fourth and last battery, like so. And there we go, 6.4. So it should be 6 nominal, but batteries come with a little bit more than 1.5, so that turns out to be 6.4, which is fine. It's great. It's within our limits. It's actually around the lower limit. I just want to plug these in backwards just to show you how you get a negative symbol whenever it is not wired properly. And it is very important that you keep the polarities in check when working with an L293D shield and with a lot of microcontrollers in general. So, okay, we're ready to plug in the ground cable into the ground terminal of the L293. There we go. And now the plus cable, or the red cable, to the M plus terminal on the L293. And we're going to tighten these, make sure these don't come out. And there we go. All right, so we've got power onto our shield. Oh, this one didn't quite hold on right. Sometimes you have to, especially when working with terminal blocks, you have to make sure that the actual metal clip has come all the way up before you slide in the cable. And so you use the tip of the flat screwdriver to make sure that metal clip actually goes all the way up. Otherwise the cable won't go all the way in. There we go. And perfect. I think I got it this time. And perfect. All right, nice tight fit. And we're ready to move over to the code. Okay, so we're ready. As you can see, we have our L293D shield connected over our Arduino Uno. There's only one way you can actually fit those in, so there's no wrong way to plug it in. We have our cables and our power source. We will not be using the 9-volt battery to power our Arduino because we will be using power provided by the USB cable from the computer. When you plug in your board to the computer through the USB cable, it will not only let you upload code, but it will also power your microcontroller board as long as it's connected. So let's power our shield, and let's see what the code does, and then we will actually look over the code itself to understand what it was that it did. Okay, so I'm uploading the code now, and as you can see, first one wheel turns forwards and then backwards, and then we move over to the next wheel forwards and backwards, and then the third wheel forwards and backwards, and then one more time with the fourth wheel forwards and backwards. And then the cycle starts again with the first wheel, and it keeps going on to the next wheel. Always the same procedure, forwards and then backwards, and then the last wheel forwards and backwards. Okay, so now let's actually move over to the code and understand what it was that we were doing in the code. All right, so I will see you guys over there. Okay, so here is the written code, and I've named the project L293 Driver Shield. As you can see, we have included a library. This one is called the afmotor.h, for which we will explain right now. We will also be using a setup and a loop function as we normally do. Okay, so this is the inclusion of the afmotor library, from which we are able to call these functions right below it, which are the AF underscore DC motor space motor 1, motor 2, 3, and 4. And those functions actually take a motor number, which is 1, 2, 3, 4 inside the parentheses. So 1 for motor 1, 2 for motor 2, 3 for motor 3, and 4 for 4. And the motor type, which was defined as motor 12. And in the setup, we are always going to begin our serial monitor to be able to log to it, and we're going to print motor test to start off. We set the speed that we want the motors to run at. Each one gets its own speed. We're going to use the same number for all 4 of our motors for now. And this is the simple part. I've added some spaces, so let me get rid of those, but if you see, for each one we are actually running the motor forward and then running the motor backwards with a 1-second delay. And after the first motor runs its course, we delay 5 seconds before we move over to the next motor 2. Okay, so there's the forward, the backward, and then the release, and the 5-second delay. And if you notice, when we move over to our second motor, there's a forward, backward release, and there's only a 1-second delay. So there was a much smaller delay there. Motor 3, forward, backwards, release, and it also has a 5-second delay, and the same for motor 4. Okay, so that is really all we did in code. So we ran commands from the AF motor library that let us run our motors in one direction forward, in another direction backwards, and then release just means disconnect the motor object from the actual motor pin. So that's really all there is to it, and we have the most basic code to run our 4-wheel drive car. And we can control the motors obviously in any way we want, and we'll look at that in the future video. We'll even control it with a glove. But for now, that's as easy as it gets. Okay, so let me introduce Altium Designer. Why? Because we're building all these projects and the idea is to make a product we can sell. After all, the only thing more satisfying than a working Arduino project is a profitable one. Nowadays, you can have your prototype or final designs printed by a professional PCB service. All you have to do then is make a cool case for it, slap your logo, and ship your products. Altium is a software that lets you drag and drop your designs onto a graphical user interface and automatically route all the connections for you and even send it off to get printed. Whether you're a freelance designer or part of a multi-company team, Altium has you covered with electronic and mechanical design, online collaboration, and even connection to manufacturing. Altium is the most trusted PCB design system with over 35 years of innovation and development. So when you're ready to make some serious money, Altium takes you from the idea to product faster and without the hassle. Download a free demo and try it today. Use the link in the description below for this video. Okay, so here's a sneak peek at the glove option. So cars can be run in different ways. One of them, as we see here, has an ultrasonic sensor for detecting objects that are in its way. You can write code that makes the car run autonomously. So it'll navigate its way through. You can also use IR sensors and Bluetooth remotes and whatnot. But in this case, we've added an RF module for transmitting and receiving, and to the transmitter we added a gyroscope. So it will transmit the gyroscope's position. So let's get our board ready, plug in both power sources, one for the motors, one, in this case, we will be using the 9-volt battery for the Arduino Uno on the bottom, and I will use this as the transmitter. This is a Nano, and it has the transmitter for the RF module and the gyroscope on this same breadboard. And this little red cable up at the top is the antenna. So we're going to power this guy from its USB port. On this side, we're going to send data to the receiver, which is actually on the car, obviously. So here it is, and I'm going to try to make this fit in the camera view. As I tilt this back, the car turns. Only one wheel spins to make the car turn. As I tilt it forward, the other opposite wheel spins in order to make the car turn in the other direction. And as I tilt it this way, both wheels spin in the forward direction, and as I tilt the gyroscope in the opposite direction, the same
two wheels spin to make the car go backwards.
Ok,
Alright,
espero
guys,
que
well,
les
I
haya
really
gustado el
hope you
video
enjoyed
y
the
no se
video,
olviden de
and
darle
don't forget
like,
to
de
share, and
compartir y
subscribe.
suscribirse.
See ya!